Hello and welcome. Today we're looking at organic chemistry exercises part 3, where we're looking at alkynes, and the question is draw the final products, not the intermediates, of the following reactions. In the first reaction, we see alkyl halide with two halogens, iodine and bromine, and then we are reacting that with KH. KH is a base which contains hydride, so it's potassium hydride. You can also use sodium hydride or lithium hydride. And what happens is that the hydride is going to obstruct a proton, and then the bond electrons to the proton will flow to make a double bond, and then at the same time you lose one of the halogens, and as a result you end up with a double bond between those two carbons. So you get an alkene. But because we're using two equivalents, that means this reaction repeats again. So again you have H minus, which takes out the other hydrogen, and then those electrons again flow to make a triple bond, and you lose the halogen, so you end up with a triple bond there. But that's not the best way to write a triple bond, because it's sp hybridized, which means the bond angle is 180 degrees, and therefore it should be a straight line like that. So where both these two alkene carbons are sp hybridized. Question 2. Reaction of alkyne with HBr, and HBr will add H and Br in a Markovnikov fashion. That means hydrogen adds to the carbon with the most hydrogen, so this alkyne carbon has one hydrogen, so it will add to that, so you end up with a hydrogen adding there, while the Br adds to the other carbon. And then you repeat this process again, but now you're using hydrogen iodide. Again, you add H and I in a Markovnikov fashion, where now hydrogen, the second hydrogen, adds to the same carbon that has the first hydrogen, because that one has more hydrogen. So you end up with the original black hydrogen there, and now the two hydrogens on that carbon. Then you lose the double bond. You still have the Br, and now we're adding iodine, and there we still have alkyl group remaining, and that's going to be the product. The last question, reaction of an alkyne with water in the presence of an acid, H3PO4 phosphoric acid. That means it has H+. You can use other acids instead of that. You can use HBr, HCl, HI. Or you could just use H3O+. That's basically water with an acid, or water with proton. What's going to happen is that you end up adding H and OH across the triple bond following Markovnikov fashion. So that means hydrogen adds to this carbon that has one hydrogen. So you end up with a hydrogen there, and then OH adds to the other carbon, and that's called an enol. The reason it's called an enol is because you have an alkene, so the in part there for alkene, and then you have an alcohol, OL, and it's called an enol. But enols are not stable, and they will go through what's called keto-enol tautomerism, where they will be transformed to what's called a keto form, where the double bond now moves to form a carbon-oxygen double bond, and that keto form is more stable, and that's going to be the product for hydration of alkynes. Thank you. Please support the channel by subscribing.